Hey, what's up, guys? This is Chung here. Today I'd like to talk about this 174 dungeon game. I think this is very interesting problem. Okay, so let's take a look. The blah blah blah. There's a dungeon and there's a knight and there's a trapped princess. Okay, and there's 2D dungeon here. So you know at so the knight starts at top left corner, and the trapped princess or the imprisoned princess is located on the bottom right corner. And on each of the cell here, there's a health, or there's you know there's a magic orbs, or there's a trap. Okay. Basically, the negative numbers means that so the knight will lose this number of health, and the positive numbers that the knight will gain like additional this number of health. Okay, and the problem is asking you to, and also of course the knight can only move to the right or down below, and it asks you to find what's the minimum initial health the knight must have to be able to for the knight to be able to reach to the princess. And remember, so the knight has to keep his health at least one at each of the step here. Okay. So for example, this one, the knight, I mean, it gives you an example here. So the minimum house the knight needs to have is 7, which means that, at with 7 here, so the knight at the first step, the house becomes to 5. Okay. And then he cannot go down, right? Because if he goes down, he dies. Okay. So he has to go right. So now his house becomes to 2. And then he keep going right, because if he goes down, he dies too. Okay, so here his house uh becomes to 5, and then he goes down here, the house becomes to 6, and then finally the house is 1. Okay, it has to be 1. Remember, it cannot be 5 here. Otherwise, even though to he managed to meet the princess, but he already died the minute he entered this final cell here. Okay. That's why the final answer is 7. Okay. Okay. So, I mean, at the beginning, at the first glance, right? I mean, it's not. I think it's pretty obvious, right? This one is like a DP problem. Basically, you just need to find at each of the step here, right? You have to gather from the 2 directions, and then you're trying to get the minimum health or the maximum value out from it. But the tricky part for this problem is that if you do it from top down, okay, basically, if you start from the top left corners, and then you're trying to follow his step like this, you will not get the correct answer with the one pass of DP. So why is that? It is because, it asks you to find the minimum health, right? Starting at this point, starting at 0, 0 point, which we have no idea. Okay, so which means if we start from this moment here, okay, and we have -2 here. So what's our initial health? We don't know, right? Let's say if we don't care, if let's say we just have -2 here, it means that we're assuming the knight will have like zero health. Okay. And then we're trying to see, okay, by the end, if when he reaches to the end, what's the basically what's the maximum health he needs to get. Okay, but that's basically with one set of with one path of the DP, there's no way we can solve that, because we don't know what's gonna be after that. So I mean, the best answer for this problem is that we do it from this cell, from the bottom right corner, and we're going backwards. So why this one works? Because, if we do it backwards, right? I mean, we know we have seen, we have seen we have seen all all the cells we need, right? We just solve it backwards. For example, here, right? At this moment, at the target, what's the minimum? What's the minimum we need at this cell? It's one minus the dungeon, the the values in this dungeon, right? Basically one minus 5, which is 6. Basically, we need 6 to get here, to be able to survive here. Okay, and then we're just going backwards. So now we have to get to this last place here. We have two ways of getting here, right? The first one is from up there, and the other one is from left. So how many we need? How many health we need? If we choose this path here, we need uh we need 5. We will need 5, I think. Yeah, we'll need 5 here. Okay. Yes, we need 5 to be able to get to 6, right? Because we have 1 here, right? And that's why we need 5 here. How about here? How about how many house we need to be to from this side? Only 1, right? To get here. Of course, I mean we have to be the minimum house we need for each cell is 1, but since we're gonna charge 30 more health here. That's why I mean we just need to have 1 here, okay, to be able to get to here, okay. And then how about here? How about the minus 10 here? Um, let's see here. Let me go back here. Let me follow the original step here. So we have 5 here, and then how about here? How many we need? We need 2 here. We need 2 here, and then how about here? We need like we need 5 here, right? We need 5 to get to 2 here. That's why we have 5 here, and then from here we have 7. Okay, right? So how about this one here, right? I mean, as you guys can see, we need 1 or 5 from this one, so we choose this one. But here, we need like 11, right, to be able to get to here, because we need to survive here first. That's why we need 11 here. How about this one here? This is also 1 here. Okay. And how about here? We need like we need 6 here, right? We need 6 here because from 1, because here we have 1, here we have 11, but we need at least 6 to survive here. So among this 5 and 6 here, we will choose 5 because we know, okay, 5 is smaller than 6. That's why we have 7 here. Okay. As you guys can see, if we do it reversely from the bottom right corner backwards to the beginning, and then we can certainly find our correct answer because we have already seen what's the last one. Okay. Okay, so with that being said, let me try to code this one here. So we need the M and N here, the dungeon, and N is the length of the dungeon, sorry, 0. Okay. And then we need a DP here, right? The DP is like, since we're getting the minimum from the 2 of them. So to be able to handle the corner case, we need to initialize them to the maximum size. Okay. This is like n plus 1 because we'll handle this like the corner case, right? In range n plus 1. Okay, here. Okay, so and so for I in range like n minus 1 minus 1 minus 1, like since we're starting from the bottom right corner, and the same thing for the j, okay, in range n minus 1 minus 1 minus 1. Okay, so and I think we have to we since you know our normal case is like this, it's like dp ij equals to the what, the minimum, right? The minimum of the minimum of dp I minus 1 j and dp ij minus 1, and then we minus the current dungeon value, dungeon like I and j. Okay, and then in the end here, right, I mean basically we need to have at least a 1 here. Basically what we are saying here, let's say we have 6 here, we have a 6, uh we have 6, right? And then we have like 5 here, right? We have 5 here, and then we have 1 here. Okay, remember, so the way we're getting this 11 here is that, you know, we're using the minimum, right, from the previously one, and uh we minus the okay, let's see. Minimum of this, oh sorry, plus, okay, this should be a plus 1 and j plus 1. Okay, since we're going backwards here, and yeah, sorry, okay, what I mean here, so how do we get 1 here, right? So I mean, we, as you guys can see, if we use this one here, right, I mean the minimum of this one is 6, right? 6 minus 30, right? 6 minus 30 is what? It's like minus 24, right? Which means the magic orbs here is too much for us, right? So which means that we don't need that much. Basically, if dp I and j is equal smaller than 0, then we know that, okay, we just need like 1 here, because we know that at this cells there are like way too many like magic orbs we than we need. So all we need is we just need 1 health to be able to get here. Okay, but as you guys can see, we do a minimum of this one here, right? And the base case is the princess, right? So here we have to do a special check here. Basically, if the I is equal to n minus 1 and j equals to the n minus 1. Otherwise, since we initialize everything with the max size value here, we're gonna have like maximum size here, okay, which will be the wrong answer for the first element here. That's why, I mean, for the last one, for this one, uh, equals to what? Equals to 1 minus, okay, because we know we need at least, basically this is our base case. We need 1 house to be survived here. That's why we need like this. 1 minus that. Else this. Okay. Of course, we have to do the same thing for this for both cases. Okay. So that we can just reduce this unnecessary orbs to just 1 here. And in the end, we simply return like dp 0, sorry, 0 and 0. Yeah, think that's it. Submit. Yeah, cool. So it passed, right? I mean, the time complexity, of course, is like O of m and n, right? M times n, and the space complexity is also O of m times n. Uh, yeah, I mean, this one is not. I mean, for to think it backward is a little bit like tricky. But okay, so next, someone might have asked, but for some people, it's not that easy to think it backwards, right? What if we really try to solve it from top left to bottom right? Can we solve it? I mean, the answer is yes, but to do that, right? Like I said, we didn't know the if we do it from the top left to the bottom right, we didn't know what was the answer, so we couldn't solve it in one pass. So what can we do? We have to do a binary search. So what does it mean? It means that we try all the possible initial health. We try all the possible initial health, and then we do a binary search, and then we find the minimum value that satisfy that the knight can still survive to get to the princess. Okay. Okay, let's try to do that. Okay, since it's gonna be fun. All right. Even though it's not the optimal solutions, but I think it's worth mentioning here. Okay, so sorry. To do that, right, for the binary search, like always, we need to find the left and the right boundaries. So what's the left boundary? The left boundary is 1. That's going to be our minimum health. But how about the right? How about the right boundary? What's the right boundary here? So the right boundary is you know, it's the total sum of all the negative numbers. That's going to be our right boundaries because, if we have the length have all the the negative numbers, that's going to be our can cover all the negative numbers here. It's guaranteeing that. I mean, the knight can reach the final the princess, right? Basically, that's gonna be our right boundaries here. So basically, I'm just going to do a simple for loop here. Okay, and that's the for loop to find all the negative numbers. Okay, and if the dungeon, right, dungeon ij is smaller than 0, okay, and then write uh, plus minus dungeon. Okay. Yep. I think that's that. But is that the answer? Probably not, right? I think we have to start it. We have to initialize it with 1. So why is that? Because remember, even with the right boundaries, we after all the summarizing all the negative numbers, that's gonna like counterparts all the negative numbers, but the knight still needs one house to be able to survive. That's why we need starting from 1. Okay. Okay, and then now the next one is the binary search template. Okay. So like always, so we have a middle here, right? The left plus right minus left divided by 2. We do a right minus left just to avoid the overflow. Okay, and then next one is going to be our Halper functions. So basically, in this case is can survive, right? Can survive with this middle health. If it can, okay, so now it's the part for the binary search. Since we're trying to find the minimum value, okay, so the minimum, so remember this. So every time when you guys need to find the minimum values, you always do if it satisfies the current conditions, you set the right to the middle, and then the left with the middle plus 1. So the reason being is that with the left and right, okay, with the left and the right, since we're trying to find the minimum values, basically we're trying to shrink the right pointer as as to the left as possible. And the reason we're doing the equal here is because since the middle satisfy our conditions, right? I mean, the middle could be our answer. So that's why we cannot do a middle -1. And we have to include the middle. And then, but we are trying to shrink this right to the left until until we cannot shrink it anymore. Then either the left and right is our answer. Okay. As for the other branches here, since we know, okay, it cannot survive, then we know, the middle is definitely not our answer. That's why we can safely change the left to middle +1 because we know the middle is not our answer. And since we're doing the left equals to middle +1 here, we don't need to do a +1 here. Okay. I think I have explained this a few times in my videos. The reason being is that if you're okay, so for example, if you are trying to find the maximum value, in that case, so this Halper function, when it is true, we're going to do a left equals to middle and the right equals to middle -1. Okay, we're going to reverse, but if you're doing the left equals to middle, and if we don't do a +1 here, right? I mean, for the case of 3 and 4, the final answer is also 3. So basically, we'll end up stuck at this if statement forever. So that's why if we're assigning the middle to the left, we have to do a +1. Okay, but in this case, we don't have to do it because we're using left equals to middle +1. Okay, so then we simply return the left. Now, it's how can we implement this can survive, right? I mean, this part is a little bit tricky to implement because the way we're implementing this, we're inside, like I said, it's another DP. Because now we have the initial house for the night. All we need to do is we just need to check with this initial uh, house, can the knight find a path to reach basically to rescue the princess? Okay. And okay, so to do that, I mean, we have to initialize our DP here. So what's gonna be our answer here? And since to be able to walk through at each of the cells here, we're gonna collect the maximum house from 2 directions so that we can use the max one to be able to get to the current one. Since we're collecting the maximum values, right? I mean, to handle the corner case, we need to initialize all the house to have the negative maximum value here. Same thing with the n+1 for this one in range n+1. Okay, and cool. So same thing for I in range. So in this case, we're doing like from top left, from top left. So we have to do n+1 for j in range 1, n+1. Okay. I mean, here it's a little bit tricky because, why is that? Because some of the path is not valid. Okay, like I said, I mean, uh, so let's say when we are at 7, when we have 7 here, right? Let's say we have 5. We have 5 here. I mean, we can go either go down or go right. Okay, but if we go down, here, I mean, basically the knight will be that. So which means this cell is not a valid path. Which means when we are at this minus 10 here, this cell should be treated as an invalid path. Okay, but how can we do that, right? I mean, basically we just to be able to mark this cell to be invalid, we just need to keep it like a negative. We just need to keep that this value to that cell. Okay, so I mean I'm gonna try to write the most common case here, right? So the most common case is this, right? Basically max from dp like I minus 1 j and then dpi j minus 1. Okay, and then we do a plus. We and then we can include the current dungeon's value. Okay, I minus 1 and j minus 1. That's our like state transition function here. Okay. Mm, but the problem is this, right? The problem is like, and let's say for this case, right? For this one, let's say if this one, for some of the cases, uh, it is smaller or equal than empty. So it means that okay, the knight will be dead, right, at this cell. So for that one, I mean, we cannot keep this one at 0 or like a negative value, right? Let's say at this moment, let's say that the this dp value is minus 1. Okay, so minus 1 means that okay, so the knight is dead at this cell. But if we leave this minus 1 to this cell here, okay, and basically it means that the knight can still use this path to keep going forward, right? But which is not correct. If that's the case, it's gonna lead us to a wrong answer. Because later on, let's say if the knight is fine here, let's say the knight can survive here, even though it's like negative 1, but it can still use this one. But then the next one is 10, then right, if the next one is 10 here, okay, so the knight will become alive again here, because here it will be 9 here, and then he can just keep going, and then in the end he will rescue the princess, but which is not right. If that's the case, right? I mean, instead of 7, I mean, the knight can be anything. The knight can be like can be 2 here, right? Because as long as he can reach the like a magic orb to revive him from death, right? He can reach the end, which is not correct. So to be able to fix that, right? I mean, we only assign this set this dp value to a number when it is a positive number. Okay, otherwise we keep it like a negative max negative number to mark it as an invalid path. So, and of course, right, we need the base case for this one. Okay, so the base case is this, right? Same thing. If if I equals to 1 and j is equal to 1, and then the dp of I and j will be what is equal to the what? The middle plus the dungeon, right? I minus 1 and j minus 1. Okay, cool. So, and in the end, we simply return, right? If the dp like we simply return the dp m and n if this one is greater than 0. Okay. Okay, so but like I said, right, since we are like checking if the last one is greater than 0, we have to mark those invalid paths. So to mark that, we need to use a temp values here. Basically, every time when we do a temp values here, we do this, right? Else we do this temp, okay? And if the temp is greater than 0, okay, then we do this dpi j equals to temp. Otherwise, we keep this one as a negative value so that in the end, this one will be a negative value. So actually here, we can do an early termination. Basically, if the starting point is a negative value here, we can simply like break. We can simply break the whole loop because we know, okay, there's no way. Basically, the knight dead the moment he enters the dungeons. But for the all the other cases, we cannot simply stop there because there might be other paths that can lead the knight to the princess. So in the end, we check if with the current middle house, starting house, can the knight find a path meet the princess alive? Okay, so yeah, I think that's it. Let's try to run the code here. Hmm? Dungeon. Oh, sorry. Yeah. Okay. Can sur survive? Oh, survive. Sorry. Hmm. Too many typos. Come on. All right, so this one submit. Cool. So it passed. As you guys can see, only beats like only 5% of people. Why is that? So now what's the time complexity? Okay, so the time complexity is